any number multiplied by 0 is just equal to 0. So when we're given a question like this, it says find all the real zeros of a polynomial function. So it's saying find the values of x such that g of x is equal to 0. Well, there's a few things. So all I have to do is show that one of these factors is equal to 0, and I've shown that g of x itself is equal to 0. So here, with this one, if x is equal to 0, then g of x will be equal to 0 no matter what the other values are. So that was one. What about the second factor? Well, I can see that if x is equal to 4, then x squared is equal to 16. But wait a second, it's plus 16. Is there any way to get to square a number and have a negative value? No, there's no possible real number that I can plug into x squared plus 16 and come up with a 0 value. So there's no way to make x squared plus 16 equal to 0. No way, so there's no solution. For that factor anyway. What about 3? This one's a little more promising because we have a negative sign there. If x is equal to 1, then g of x, or I should say g of 1, is equal to 1 squared minus 1, which is just equal to 0. So if x is equal to 1, g of x will be equal to 0. Is there any other value? Well, what if x was equal to negative 1? Negative 1 squared minus 1 is equal to 0 as well. So there are 3 answers to the question. If x is equal to 0, if x is equal to negative 1, and if x is equal to 1, then g of x is going to be equal to 0. Now let's go to ALEK's and see if we did it correctly. I've gone ahead and added the values into ALEK's. So we've got negative 1, 0, and 1, and I'm going to click on the check button, and we got the correct answer. We've been given a function f of x, which we know is the negative of the absolute value of x. And that represents the graph in a blue color with the origin at coordinates 0, 0. Another function has been drawn, an h function, whose highest point is at coordinates negative 4, 3. And the question is asking us to write down the expression for the function h of x. So let me write out f of x, which is equal to negative the absolute value of x. And there's an implication here that it's plus 0. Why do I know that? Because if x is equal to 0, we get the coordinates 0, 0, which takes us right to here. And we know, just looking at the diagram, the graph, we know that that's the maximum. Now we want an equation for h of x, and it's going to look something like this. Well, I'll write it very generally. or maybe I'll write it as negative the absolute value of x plus a, some unknown variable a, plus b. And so we want to essentially solve for a and b. Remember that a is going to move the diagram left and right. B is going to move, or I shouldn't say the diagram, it's going to move the function left and right. And b is going to move the function up and down. Now I know that the h function has a max at the coordinates -4, 3. To move the max up, or make it, to move the max up 3 units, set b equal to, well, its original value 0 plus 3. So set b equal to 3. Means I'm going to have h of x is equal to negative x plus a plus 3. Let's call this 1. And this is kind of our step 1 here. And for step 2, notice h of x is maximized when x is equal to -4. So let's set x equal to -4. There's a couple different ways I could show you how to do this. Let's recognize that this function is equal to our y-axis value. If I do that, I can rewrite this whole thing as y is equal to what? It's equal to 3, which is also equal to negative the absolute value of -4 plus a plus 3. And if I subtract 3 off both sides of the equation, I'm going to get 0 is equal to -4 plus a. What value of a makes this true? Well, a has to be equal to 4. And now we can add everything together, and we see that h of x is going to be equal to negative f of x plus 4 plus 3, or h of x is equal to negative x plus 4 plus 3. Looking at ALEKs, I'm going to press negative, and then I'm going to touch this little button over here, which is going to create an absolute value sign for me. I've got x minus 4. Excuse me, that's x plus 4 plus 3. And let's see if we've got the right expression for h of x. I'll click the check button, and we got the right answer. This is a great question because it shows you a more general way of inputting values into a function. You can take a function and input it into another function, as this example demonstrates. This comes up a lot in calculus. This comes up a lot in economic applications. A lot of students are not familiar with it. It's not hard, but students, since they're not familiar with it, they often panic and don't understand what's happening. So let's look at this question. The question says, here's a function g of x. Find g of 5z. So everywhere there's an x, I'm going to plug in 5z. So I've got 2 times 5z squared minus 1. Now I'm going to simplify or expand. I guess I'm going to expand this expression. And I've got 5 squared z squared. So notice that the exponent comes into both the factors. Both the 5 and the z are going to be squared, and the minus 1 stays outside of everything. When I work through, getting ahead of myself, 50 z squared, forgetting the minus 1, I'm going a little too fast, but there is the answer. So if we want to evaluate g of x at 5z, we can do that. Plug it in. Everywhere there's an x, you're going to plug in a 5z. Now I've entered our answer on ALEK's, and I'm going to click the check button, and we got the correct answer. We're going to take a look at cubic functions. It's important to be familiar with cubic functions and the shape that they take on. This question is similar to one we did a little bit earlier, where we had to evaluate a number of points using the function and then graphing it. And so I'm not going to take too much time redoing that again, but I want to make sure that you understand and you know how to use the ALEK's tool and how to graph a function like this. Now, I've gone ahead and solved for it. Here are the solutions. Notice that we've got fractions. Or in this case, it's represented as a decimal, but it's a fraction, or it could be represented as a fraction. And the problem with this is it's going to be awfully hard for you to find the point negative 1.75 on the ALEK's diagram. So let me show you again the tool that we're going to use to solve a question like this on ALEK's. Here's the question on ALEK's, and I'm going to use the plot anywhere function. So I'm going to click on this highlighted little image of a diagram, and it's asking me, just to show you, it says enter the x and y coordinates of the point. And now I've got the coordinates over here to the right of the screen, so that's going to make it easy for me to input them in. So we've got negative 2, negative 14, and then I click plot point, negative 1, negative 1.75. Oops, there's a mistake. Make sure I move over 1.75, and I'm going to plot the point. Got 0 and 0, that's an easy one. Plot the point. 1 and 1.75. Plot the point. And 2 and 14. And I'm going to plot the point. So it looks like I did it properly. Hopefully I didn't make an input error. I'm going to close this box here. And then I'm going to click on these little x's with the curvy line through them. And ALEK should know that how I want the cubic function to be drawn. Now I'll move back up so you can see the question. And I'm going to click on the checkbox. And happily, I did it successfully. Let's take a look at set theory. Set theory is really kind of fun, and it's really important for understanding how to read mathematics, how to communicate mathematics. I'll show you this example. It's really easy, but the key is understanding the language of mathematics. If you understand the language of mathematics, you'll be able to read your textbook. you'll be able to read academic papers and really understand what those authors are trying to tell you. And you'll be able to follow those instructions, and you're going to be, that's a very employable skill. That's a really great skill to have. So let's take a look at this simple example that I put together. The question says, find the union of dark-haired people and tall people. Then find the intersection of dark hair and tall people. And we're given two sets. We've got our sets. We've got our dark-haired set and our tall set. Now, when it says find the union, what that means in mathematical language is find the people who are either tall or have dark hair. So in this example, well, Ahmed has dark hair, so he's in that union. Zhu is in that union. They have dark hair. Mo has dark hair. Frank is tall, so even though he doesn't have dark hair, that's okay. He's in the union of dark-haired and tall people. And Zhu is also tall, but we've already included them in the union, and we don't need to record them twice. There's nothing wrong with recording them twice, but generally it's better if we just record them once, because we don't want to count them twice if we were adding up all the numbers of people in this set. And Coco. Coco's tall. She doesn't have dark hair, but that's okay. She's in the union. She's still in that union of dark hair and tall people. Now, what about the intersection? Well, the intersection of dark-haired and tall people are those who are both tall and have dark hair. And I guess I could say about the union is that we'd say that this thing up here is equal to dark U tall. Right, the union of dark-haired and tall people is equal to this set with 5 names in it. Now find the intersection of people who are both tall and have dark hair. So if I want dark, an upside down U, that's a little bit bigger than a U. This symbol, the intersection of dark and tall people is going to be equal to, well, Ahmed only has dark hair, and he's not tall, so he's not tall. Zhu has both dark hair and is tall. Mo has dark hair, but he's not tall. Frank is tall, but he does not have dark hair. And Coco is tall, but she does not have dark hair. So the intersection of these spaces is just Zhu. Now here's the question that we see on ALEK's. So we're given 2 sets. The sets contain unknown variables represented by letters. And we're asked to find the union of G and M, and then find the intersection of G and M. So applying what we learned in the previous example, the union of G and M is going to be equal to, well, any of these variables that occur in either the set G or the set M. So we're going to have D, E, F, G, H, and J. Now, I tried to keep it in alphabetical order because that's the proper way to represent it. It's probably not necessary, but it's the best way to represent it. And so the union of G and M has 6 different variables in it. When we look at the intersection, Well, neither of these variables appear in both the set G and the set M. So we can say that the intersection of these two sets is empty, or it is the null set. It's the empty set. So it's empty, or it sounds a little bit cooler in English to say it's the null set. But you can certainly call it the empty set. That's completely legitimate. Here's our question on ALEKs. So the union of these two sets, I'm going to press this little button here to get the squirrely brackets that represented it as a set. And so the union, it has 6 variables in it. The intersection is the empty set. And let's see if I did it correctly. And I didn't. That's okay. I just made a mistake with the language of ALEKs. And that language is I shouldn't have had squirrely brackets around my empty set. So I've got the empty set here without squirrely brackets, and now it tells me that I got the correct answer. So remember that when you're answering questions on ALEKs, it wants the null set with no squirrely brackets around it.